Start now.
Well, good afternoon, everybody, and welcome to the third of today's webinar sessions from Smart Vision Europe. My name is Charles Quinn, and I'm joined online today by my colleague, Bernie Simmons, who's going to be monitoring and making sure everybody's logging in correctly. Just so you're aware, these sessions are recorded. And there are some slides here that I'm going to show at the start. We'll email out a link for you to download the materials after the session's ended. If you have colleagues who are unable to attend today, it may be possible for us to arrange a rerun of this session if you can get enough of them together. The best thing to do is just ask us, just send us an email. With regard to asking questions, all the lines are muted, so we can't hear you. But if you use the chat panel, Bernie will keep fielding those and make a note of them. And if we run out of time, we'll follow up with you afterwards offline. We normally do that anyway. We normally have a few emails after the session ended, and so that we can give a thorough and complete answer with links to materials, etc., afterwards. So please don't feel that you're missing out if you don't get a chance to. If we don't answer your question in the session, just bear with us, send us an email, and we'll answer afterwards. So if you don't know who Smart Vision Europe are, we are an analytics organization. We're a gold accredited partner to IBM. We're also a partner to a company called Predictive Solutions and to Data Robot, and we specialize in advanced analytics and big data technologies. We do work with open source technologies as well, it has to be said, such as R and Python and Spark, etc. And we're made up of a sort of veteran team of people who have a lot of experience working in the advanced predictive analytics industry. Myself, I've got coming up on 30 years experience working for SPSS, IBM, and SAS Institute as a senior analyst or consultant. And that means we've got a lot of experience across lots of different applications and lots of different sectors from both private sector and public sector, of where AI, machine learning, statistics, data mining, whatever it is you want to refer to those applications as, is applied. Okay, today, this is a new session for us because something which has been bubbling along in the background in the IBM world is the development of their Watson offering, which is their sort of AI and data platform. The latest incarnation of this is referred to as Watsonx. And there are 3 flavors to it, which makes it a little bit easier for people to, I think, kind of understand now that they've got 3 flavors of it. One is Watsonx.ai, which is what we're going to focus on today. And this is an area where you do all things related to AI, such as training and building and tuning AI models. The second area is Watsonx data. This is really about the management of data and AI workloads and combination of data, whether it be things like data lakes or third-party online data systems that you need to connect to, and you need to control and make sure it's staged correctly. And then there's Watsonx governance. Governance is a very hot topic within the AI world at the moment. It's about making sure that any decision making that's triggered off machine learning or AI platforms is sufficiently transparent, that you can explain it, that it is fair, and it is ethical. So monitoring that and making sure that there isn't, undue bias in the decision making that's happening there is a key concern of a lot of quite mature adopters of AI technology these days. And as a result of that, IBM have a fairly robust answer to it. So we're going to be looking at Watsonx.ai. This is described as the next generation enterprise studio for AI builders to train, validate, tune, and deploy both traditional machine learning and new generative AI capabilities powered by foundation models. So the AI capabilities powered by foundation models, I'll come to in a moment. We're not going to touch on that today, but I need to point it out to you. Watsonx.ai is traditionally, if you haven't encountered that platform before, you may have heard of Cloud Pak for Data. Cloud Pak for Data is kind of the terminology that's employed. It's the foundation for the online browser-based world, whereby you would you would interact with the AI capabilities within Watson's and IBM stable, of which there are many. You can almost think of it like a periodic table of lots of different AI solutions and capabilities and software, and you can pick them. So this is by no means an exhaustive list, but the sorts of things that one might associate with Watsonx.ai are things that we're going to focus on today. Visual modeling. If you're familiar with IBM SPSS Modeler, this is very much an online browser-based equivalent of that, where we are using workflows to visually interact with data and to build predictive models or segmentation models or other types of AI type applications. There's AutoAI, that's sometimes called AutoML, which is the ability to automate model building process, including to a certain extent the preparation of the data, the feature engineering, and the switches, basically coming up with the settings for a model that are optimized, what's known as hyperparameter optimization. And then there's things like combining different work prep pipelines, given the fact that data scientists these days are liable to work with different tools. Different data scientists may work with Python, or work with R, or work with a visual modeling approach, or maybe somebody's working with AutoAI. You need to be able to combine these together at a higher level. So being able to collaborate and combine different work streams together. This is what ML ops pipelines helps deal with. And you have decision optimization. This is about optimization algorithms, which solve problems like what is the optimal price to offer in, say, a car parking scenario where you've got dynamic pricing there. And this is a particular realm, of course, of AI technology, and it's a mathematical realm of linear programming. So streamlining the selection and deployment of optimization models, including dashboards, creation, and sharing results. In the world of optimization, things like a likelihood or a risk value or propensity value that a machine learning predictive model produces is an input, along with pricing and constraints, and time is an input into the decision making that one has to make in order to come up with the optimal recommended decision or route to take. And then lastly, generative AI. I've highlighted this mainly because if you look up anything about Watsonx.ai at the moment, you'll see a lot about generative AI. So this is all about this chat GPT type technology, which is based on foundation models. Foundation models, turns out that Watsonx.ai has a number of different foundation models which are based on billions of parameters and which work with different sorts of scenarios. It has a little prompt lab which allows you to test out things like NLP type tasks, such as answering a question. So you could give it a document and then ask it to summarize that document. You could give it a number of different pieces of text, let's say from a review website, and ask it to rank those texts, those reviews, those open-ended text reviews, say on a scale of 1 to 5. So classification, even things like estimating the net promoter score based on, I don't know, the reviews of a coffee shop, all that type of stuff you can do inside their little prompt lab environment, choosing these different fundamental large language models, these foundation models, to play with. So it's a big element of Watsonx.ai. And the reason I'm highlighting it there is because you'll see a lot of it. They almost lead with this when they talk about this particular aspect of the Watson platform. Okay, let's take a look. Well, first thing I got to do is I got to log in. So let's see if I can log in here. So, Smart Vision here. We've been working with customers who have been using the Watson platform for a while. We've been playing around with it ourselves. When you log in, as I'm doing here, you're going to get to this sort of dashboard landing page, which tells you things about recent support cases, tells you how much money you're spending on the platform, because obviously it's going to be charged based on the volumes of data and the compute power that you have there. I haven't really got time to go into the details of what capacity unit R's are, but suffice to say it's charged on a usage basis, although we will talk about how you can work with it for free if you want to try it out later on. The point is that we have some resources here, and if I click on my resource list here, I've got you can see there's lots of different potential resources here, of which too much detail really to go into blockchain and developer tools and logging and monitoring. All my stuff is here under AI machine learning, and I've got a number of different environments here, instances, if you like. So if I click on this Watson Studio POC, which is part of a little resource group, that's going to take me into it. And you can see here, because they're kind of at an inflection point between the old almost heritage Cloud Pak for Data environment. You can launch in that traditional environment, or you can launch in Watsonx. And given that Watsonx is kind of the latest new kid on the block, I thought we should probably focus on that. So I'll click on Watsonx and we'll launch on that, and so you can have a look at it. I think that this is probably what most people are going to be seeing. When you land on that, it says welcome, and it allows you to take a tour of that, etc., etc. I'm not really interested in that. I'm really interested in the sorts of information that we've got and the projects that we've got here that I've been working on. So I've been creating some training projects, and there's a little sample project here that deals with home insurance. So let's click on that and see what happens. So right away, the first thing we want to do is we want to look at what is a project, and what do we see in a project, and what can we do with a project. So you get to this very simple landing page here. It's an overview here. Tell me about this project history, how many capacity unit R's it's used up. See, Bernie's created it here. And I've got inside this project different assets, different things. You can see them broken down here. I've got 3 data assets, so I can highlight those. And there's 3 different data files. I've got 2 modular flows, which I'll talk about in a few moments. I've got something called an AutoAI experiment, and I've got a notebook. Okay. So I've got these different things. How do I get the data in there if I want? The first thing is if I've got just some let's say flat file data or something like that, I can just click and drag them. And I've got one here called Health Club Contacts. And it's just a CSV file. So you can see me just uploading that. And it says I've uploaded it. And I can go and have a little look at it and check and see if it makes sense at this stage, and investigate it a little bit. We talk about that in more detail, but you'll see lots of examples of it. I can right click here and say, prepare the data. If I start preparing the data, it will actually start a task called the data refinery task. And it allows me to start playing around the data and cleaning it and that sort of stuff. The key here is that that's not the only place where you can do that. Where you can, there's lots of other places where you can prepare and clean data. It's just one of them. You could use R, you could use Python, or you could use, as you can see, we could use the modular flows that we have available to us. And again, if I want to delete any of these, I could delete them as well and get rid of them and say one item selected, Health Club Contacts.csv, hit delete, and just deletes it. But what happens if it's an actual online like a data lake or something like that, or it's an Amazon S3 database? It's not really a flat file. Well, in that case, I would probably click on import asset. Oh, sorry, click on new task here. And this is where it opens up all the different things I can do, or I've got availability to do, or I've got access to do in my instance of working with Watsonx.ai. One of the first things you see here is everyone gets this, is connect to a data source, and click on the connect to a data source. And you can see this is just dizzying range of different data sources that you can have, from Amazon S3 through to lots of different types of IBM cloud databases, through to Looker, SAP, Salesforce, etc., Tableau, Teradata. I could click on one of these. I could select that and I could start, setting up a connection to it, giving it connection details, telling it what the host IP address is, what the port is, giving it credentials, etc. And once I've done that, of course, I can then test the connection. And basically, I've then, for that project, I've got a kind of data connection that's already set up, and that would appear here under the actual connections itself. It would be something I'd be able to call on a regular basis, in the same way that I can simply reference one of these data assets, which is available to the project. We've got, as we can see, 3 of them here. What else can I do under new task here, just while we're talking about it? You can see that I could connect to source data. I could generate some synthetic data if I wanted to just create some synthetic data to play with. I can start with data refineries, it says here, to prepare and visualize data. Worth playing around with if you want to have a little go with it. Allows you to do things like, create a ratio of one field to the next, or, deal with extreme values and visualize the data. I could, as you'll see later on, I could build models automatically using this AutoAI function. I could build models using a visual flow, which is what I'm about to demonstrate, which is this sort of modeler type interface. I could work with R or Python. I could solve optimization problems, or I could train models on distributed data. That means training models on distributed data is a really interesting feature, where if different people have different data sets, in other words, the data is actually distributed, and they wish to sort of submit them or have them contribute towards the a central model, then the models can be trained on these different data sets without anybody being able to see somebody else's data set, if you like. So it has a lot of advantages where people can kind of contribute their data, or donate their data, but retain animosity to it. So it's a very particular set of circumstances. So building models as a visual flow, I've actually got some visual flow assets already created here. If you're familiar with IBM SPSS Modeler, these are like streams. I've got one here referring to the home insurance data set that I uploaded earlier. It's called the home insurance expiration modeler flow. And if I click on that, that opens up or starts an instance of that modeler flow. You can see here that depending on my pricing plan, and depending on how much compute power I want, the default is it'll give me 2 CPUs and 8 gigabytes of RAM. I could go for just the middle here and say I want 4 CPUs and 16 gig of RAM, and hit start runtime. And at that point, it does take a minute for it to do this. But in that spirit, if you wanted to kind of compare and contrast this online browser-based interface into the to SPSS modeler, within the context of Watson, you can compare and contrast it to its older brother, if you like, or older sister, which is the client-based version of it. So you can see the client, here we have what it calls a modeler flow, in which clients call modeler streams. And you can see down the side here, we have data sources, we have things that we do to these different streams models. So this is a visual interface. You'll hear a lot of people talking about low code, no code, and code. So code is where I'm typing into Python or typing into R. No code is when I'm just running something like an AutoAI experiment and everything's done automated. And low code is often this kind of visual interface where you can, it's not pure code, it's kind of a visual code. So back in the background here, we've basically landed on a kind of blank stream, a bit like this, except this time all these palettes are not along the bottom, they're actually along the side here. But it's a mirror image, so pretty much everything I see in record operations there, I'm seeing in record ops here. It's pretty much exactly the same. So this is just the online equivalent of that. So if I wanted to start building a stream here, I could click on the data asset and drag that across data asset node. Now we know that in this project there are 3 different data assets, and if I want to connect to one of them, I'm going to click on this and hit edit. That opens up a little edit table, and then I'll just say I haven't got an online connection defined. I've got a data asset connection down here, and I can say, okay, it's this home insurance CSV file that I'm going to select. And that selects that data set. And if you know anything about Modeler, you might not, but if you know anything about Modeler, one of the things it does is it reads the data, it scans the data. And this is true within not just old school modeler, client modeler here, using what's called a type node. It's also true within the online version of it, the thin client version that we're accessing here. What that does is it scans the data, and the idea is that it's just easier because if it scans the data, it's already got information about all of the data, and you can kind of configure the data and identify what everything does and what type of field it is before you start modeling it. So it's like you're front loading your efforts. So we've got, for example, here we've got customer ID. Is it an input to a model? No, it's not. It's basically a record ID. Age is a potential input into our model. Income is as well. Children is an input. There's only values of 0, 1, 2, 3 here. So this is more of what we would call an ordinal field. And then I can see these fields here. We've got like 1 and 2. This is not really a continuous field. This is actually a flag field, meaning it's binary. This one here's got 1 to 4. This is the region. It's not really a number. It's nominal. So I'm deliberately doing this. I could set this up. If these were strings, if this was just like true and false, then it would automatically identify them as flag fields. It's just it doesn't know from a CSV file what kind of role they perform. So I'm going to set all these guys here, 1 and 2 meaning no and yes. They are flags. And our key field that we're interested in here is our target field, which is home insurance. So the situation here is that this bank is offering home insurance, and we've got all this information about these different customers, and we're trying to predict, potentially which customers we should be offering home insurance to, based upon their demographics and based upon their transactional history. Have they got a savings account? Have they got a current account? Have they got a mortgage, etc., etc.? And there's only 300 cases in here. So if I click save at that point, and I'm just exploring the data at this point using this data asset. Well, what things I do to explore it? Well, I might visualize it. So I might go to the graphs here and connect up a charts application here, a little charts node, which allows me to launch a chart builder. I could launch a chart builder at this stage. And, I could do something like a little scatter plot here. Let's do a scatter plot of, let's say, age to something like disposable income, colored by whether or not they have this key outcome here, insurance, where 2 is yes and blue, and 1 is no. That's blue. So it doesn't look like there's much of a relationship there. It looks like the yes group is kind of, it's kind of all the way across this distribution here. I could give these labels. I could go back into the type node and just give it labels to make it easier, but it makes sense to me what they're doing. I could change the size of this and say, okay, look, I'm going to make the actual income, the larger their income, then the larger the circle. I could change the shapes. I could alter it and say, actually, I'm more interested in doing something like a histogram, something like that. So I want to look at a little histogram, something like that. So, or a bar chart if I had category fields, or you can see there's a whole bunch of different category variables here and a lot of different charts here I could play around with. So suffice to say, if I wanted to explore the data, I've got a lot of different ways in which I could do that. Here's a box plot. Let's do a box plot of, say, disposable income split by, let's say, the region that they're in or something like that. Doesn't look like it's changing very much. It looks pretty much similar. And we could select individual ones of these. We could normalize the data. We could play around with it in various ways. And we could also go to these various options here, like actions, and say, okay, I don't really like the colors that you're using here. I want to use a different theme. Go carbon dark and apply. And you can actually build up a little sort of report interface here with multiple charts on the same report at the same time as you start to build this report, and then save it as a visualization. If you're not particularly interested in that, you could just say, okay, well, I'm going to go back to home insurance itself. And I will look at this flow again. So let's go back to this flow again. Let's open the flow again. Where is it? And say instead, I'm really interested in auditing the data. I'm really interested in exploring it using an output like a data audit output here. So there's another way I can execute this. I can run this. This is particularly geared towards identifying any problems in the data. So it gives me reports on how many valid cases you have, how many missing values you have. So it's giving me a little overview. Here's some of the sort of things we saw earlier on. There's a histogram of age, for example. I can play around with. I can see that as a box plot. I can do various sorts of analyses of that. I can see it as a, if it's a time series, it will show me as a time series and decompose it. It'll also show me how many unique characters are, the mean, the maximum, this, how many valid characters there are, how many missing values there are, etc. And give me a lot of control over how complete it is, the quality controls here, how many outliers or extremes there are, etc., etc. So this is all about exploring the data at this stage. If I wanted to, let's assume I've done enough exploration at this point, and I wanted to say build a model. There are various ways in which you could do that. Probably a smart idea would be to do something to the data beforehand where I partition the data. Normally, I've only got 300 cases here. But partitioning the data just means to split it into training and testing partitions. So I build the model on 150 cases and I test it on 150 cases and test it on the 150 in the test sample that I've held back. So I might go to the modeling node here and say, okay, let's look at, I don't know, C5 here. This is a type of decision tree type model. And if I run that and execute it, it's exactly the same if I'm working in the client version of Modeler. It produces a model for me. It looks like a sort of gold object. That's what that's meant to be. I can double click on it. I can ask it to show me confidence scores, etc. And I can click on it and say, view the model. And it's going to show me a little decision tree, or going to give me overall which fields are the most important: disposable income, children, car, etc. So I can actually see which the most, I can see the most important rules, and I can see the model as a tree diagram. I can zoom in and out at that and see what the most important factor is. There's disposable income, really important. It's used that. It's split the model by that. I can move around here a little bit and look at the other factors in it, which have broken it down. If I look at the training summary, it'll tell me how it's been built and the build settings and what sort of settings it had associated with it. If I'm not really sure about that, I could, for example, run another procedure here and ask it to try out lots of different types of models. This is called an auto classifier. I run that. That's going to try out a whole bunch of different models. If I run that, it's going to take a while for it to do it as it tries out all of these different models. So that will include a C5 model. And there'll be a default setting in there, which is, select the top 4 or something like that based upon some sort of accuracy measure, how well they do at predicting the 2 categories in the home insurance group. There are different measures that one could use. This might be overall accuracy, or it might be a lift value, but basically it ranks them in order and says, this algorithm works really well. So it's trying out a whole bunch of these algorithms. Some of them are decision trees, like we saw. Some of them are things like quite high-end machine learning algorithms, like what have we got? We've got things like support vector machines, and we've got things like XGBoost, which is a very popular one. We've got real traditional logistic regression. Let's see what it's done. If I click here and say view model, we can see how it shows them. So it looks like it's looking at overall accuracy. XGBoost is the winner. There's logistic regression, depending on what type of model it is. But look at logistic regression. It's saying, okay, here's the parameter estimate. So it's showing me a statistical model, different B values, different coefficients. That basically allows me to create a formula, an equation from that, which will predict and create a probability value, the probability of being in the yes group. Quest is a decision tree that it's using. It's actually, in this case, it's just a really, really simple decision tree. It's just saying, and splitting them by children here. If I zoom in on this, it's basically saying, if you've got less than or equal to one kid, then I'm going to say that 44% of you are in the yes, I'll buy in home insurance group. And if you've got more than one kid, I'm going to say 29% if you buy it. And if your disposable income is greater than 15,000, then all of you buy it. There's only 6 cases in there. And then XGBoost is just a much more complex decision tree type model. It's possibly going to overfit in this case, which means it's probably going to predict it kind of close to perfect. But anyway, it's doing its thing. The key here is that all of this is finding patterns, and it produces some sort of output for you. That these models, the point about these models is they have to generate new data that didn't exist before. And if I actually put a data table on the end of this, the values that's generating will be from a combination of the models. It will actually be combining them together and actually voting as if they were voting. So it says the overall, this is called an ensemble model. It says I predict this person to be a 2, as in they will buy home insurance, and I'm 73% confident of that prediction. I predict this person to not buy home insurance. It's also correct there. I'm 93%, confident of that. It also indicates to me whether or not these cases were part of the testing or training groups. And I could go in here and switch these off and say, okay, look, I could view the model here. I could say, actually, you know what, I don't want you to use this one. Just use the top 2 there and delete them. Or I could cherry pick one of them and say, I just want to use logistic regression. I just want to use XGBoost or something like that. So this is kind of an interesting way to work with the Watson environment. We're working here with a visual flow. You can see here I'm going back and just deleting it. One of the aspects of working with the visual flows is that you have the ability to version control stuff. So it's automatically saving it as I'm going along. So I actually have 2 versions. I have the finished version, the empty version. The empty version is what I start with. If I go to the finished version, it's kind of like this is the complete version, and I hit revert here. Oh, it's disappeared at a stage. It's gone. I've obviously lost it at some stage. I've overwritten it at that point. And the empty version is the original version, but the finished version maybe it's not there. Maybe I've deleted it, but you can version control stuff as you're going along. And one of the things I wanted to show was, well, okay, what if I wanted to actually use this model that I'd created earlier on to score some data? So in other words, if I wanted to create like a batch job or something off that, well, I've got a data asset here. I've just started off. It's the same data set. This time I've chosen the XGBoost model. I've kind of cherry picked it. I've pulled it out and said, yeah, that's the one for me. I want to use that. When I open that, it starts a new session for me, so I can just pick these up. And in terms of what I'm actually going to use to score, I'm probably actually not going to ask it to create a scored data set of all the fields that we use to build the model. I'll probably just go into filter here, use a filter node. And if I use a filter node, I can say switch off, don't let any of the fields through apart from customer ID and apart from these last 2 fields that you've created. One is your prediction category. Are you a yes or a no, if you like? Are you are you a home insurance buyer or not? And this one is confidence. I've got that, and I can hit save at that point. And then if I show you what that looks like, I can right click here and say, okay, we're going to preview the data. Let's preview the data. It'll just give me a little preview of it. And it'll show me what the data looks like. That's going to create. So here you can see the data file is going to create customer ID, prediction category, and confidence. So that's what our scored data set. Where is it going to go? Well, it has to create a data set for me to kind of create a batch job of that. So what I could do is just create a data export here, double click on that, and give that a name. It's going to create a little CSV file here called output.csv by default. It's just going to make a CSV file. Like other formats I could use, like Excel or different type of delimitation, say using pipe delimitation or tab delimitation. Let's see if I should have a version control for this one as well. Let's just see if I look at version here. Let's see if this works. If I go make current, revert, see if this is working. It also looks like it's trying to open the flow. I'm only using the current version because I've already created the data set and I didn't want to end up with lots of different data sets. If I double click on this one, what's it called? It's called home insurance scores.csv. So this is just a complete version of that stream that I was building. If I then go to this button up here, it's meant to have a little timer next to it. I can say new job. So I can create a batch job from this and hey, create a job from that. And it says, well, how are you gonna identify this? And I'm gonna call it insurance job 2. I think I've already done this in the past. I can tell it how many gigs of RAM it has available for it. And how many CPUs it needs to run it. I can say click on run job retention settings, which is you can retain this job and the assets associated with it. In other words, the kind of log files that it creates for 7 days, and then just delete them if I don't want it to kind of clog up with logs and stuff like that. I can say save as a new flow, or I can hit next at this point, take me down through it. Flow parameters just refers to the fact that in modeler streams, you can actually add in stream properties, you can add things like parameter values. So it's like, if you're going to run a stream that would pop up and say, I've got a parameter here for the region. Which region do you want me to run it against? Want to run it against Midlands? And I've got a parameter here for the month. Which month do you want me to run it against? Want to run it against January? So in this case, there are no parameters associated with this. It's just running against the whole file. And configuration, run the flow or run branches. But this might actually be a branch. It might actually be branching. And the flow doesn't necessarily just be straightforward. It could have different branches in it. In this case, it doesn't have branches. And then we get the schedule. And I could say schedule on. And I could say, okay, let's define when you start this. And I got a little date here, today's date. And at the moment, it's 15:37. So I could say, okay, I want you to run it at 15:38, and then hope I get to it in time, and say, do you want to notify me for this? Yes, I do. Hit next at that point and say, create that job. And off we've gone. We've gone off and created that job, and it's running there in the background at that point. So that's how we would deploy it as a job at that point. So if we went to home insurance now, we can see that there are jobs associated with this. In fact, there's one I did earlier, home insurance job. Oh, this one's failed. Why is it failed? It's probably because the data set doesn't exist or something like that. Oh, the user IAM credential not found. That's fantastic. Okay, that means that my credentials have probably expired on this. I kind of suspected something like that might happen, so that's why I created an earlier version of the job. I've got this one here, home insurance job. You can see here, 3 have been completed at this stage. We haven't. Have I got the rights to actually view it at this stage? I'm not entirely sure if I have. Let's see. Yeah, it's just telling me that it started that run. It's setting up that job. It's running it. It's complete. So that's the log file it's created. Maybe I could rerun an earlier job. Let's just try it as an experiment. This one's completed. If I click on that, can I rerun it? Maybe not. Usually there's a little button here to rerun. Let's try this one. Check this and say run job. Let's see if it runs it. Okay, is now running. I can't guarantee it's going to work because obviously if the credentials have expired on my instance of this, but what it says is it's starting there, and you could refresh it, and it'll say eventually running, and it will say eventually completed. But in principle, if you want to take a stream and you want to submit it for a batch job, it's got to have a start point and an end point. It's got to create something. It's got to have everything it needs in that stream to create an output. The output might be, it might be a report of some sort. It might just be a graphic that you're producing. If you're scoring data, the output is normally a data file. So you can see it's running here in this case. Let's see if it's going to finish it. It's going to complete. I suspect that what's happened earlier on when we were running through the when we're running through the setting up the job, you may have noticed there's a thing called an API key. That's like a little identifier, a little token that you can copy and paste. And I think the API key has probably depleted at that stage. It's no longer working. Anyway, this one here is finished. So we just used an earlier version of that job and we've rerun it, just manually clicking on that. Okay, let's go back to projects here. That's us looking at the Watson Studio modeler platform, if you like, the Watson Flow platform. What else have we got within it? Well, we've got other stuff here. We've got things like AutoAI. So AutoAI, it's a bit like the auto classification that we saw earlier on, except this is almost like a sort of nuclear option where you're saying, I absolutely want to build the best model I can possibly build, and I want you to do the feature selection. I want you to find the best variables that should run in that. So I want you to analyze that. I want you to transform or change the variables. Maybe you want to take the log of a value, or maybe you want to remove extreme values. And I want you to try out different settings for each of the models. This is called hyperparameter optimization. And I want you to try to optimize some sort of result. So this is the results you get. Let me see if I can go back to home insurance here and say new task. Let's see if I can create one from scratch. If I say build machine learning models automatically, and then we'll go back to that other one while it's building. Let's see, define a name. Let's see, I think it's AutoAI. I think I got one. I think I got a little data set called bank. Underscore bank, something like that to play with. Where am I getting that from? I'm getting it from the samples here that's got to play with. I say bank marketing data. This sample file contains data from phone calls to a Portuguese bank in response to a marketing campaign. The goal is to predict whether or not a client will subscribe to a term deposit represented by the variable Y. I hit next at this point. So yes, it's going to use this configuration. It's got this sort of this environment definition. How many? 8 CPUs and 32 gigabytes of RAM. And I can hit create at that point. Let's see if it starts running. So it's saying at this stage it already knows because this data set's actually been set up to do this, that it's trying to predict a binary outcome where the class it's trying to predict is the yes group, people who will subscribe, and it's optimized for a measure called the receiver operator curve area under the curve. It basically means a fit statistic where the larger that value is, the better it does at the accuracy. So it's optimized for ROC, AUC, and runtime. If I click run experiment at that stage, it starts the process of trying out many different algorithms and choosing them. So you can see here it is. It's saying it's working away in the background here, and it's trying to optimize based on the ROC. It's using cross validation. Cross validation is where you're using sections of the data, different sections of the data, and you're testing, you're building it on one section of data and testing it on the other section of data as you're going along, which is different from what the type of model building I was doing earlier on, where I simply had a training and test group, which I'd split the sample into 2 groups. That's another alternative approach. This one uses validation at this stage. So at the moment, it doesn't look like it's doing much, but eventually you see it starting to build models in what it calls a pipeline. So at the moment, 46, so downloading source data, 46 data. So here it is. Training data is 90%. The holdout data is 10%. It's held back 10% of the data. I think this is quite a tricky one to predict, so it doesn't predict anything like as well as the model and the insurance model predicted earlier on. And here it is, it's selecting the algorithms as it's going along. While it's doing that, let's go back to home insurance. And let's look at the other AutoAI that we were running earlier on, which is AutoAI Home Insurance. It's using the same data set. So you'll see this is the result of this. This is how it's going through this. If I swap view here, you can see there's two different ways in which it's building these sorts of pipelines. And a pipeline basically means I'm going to start by reading the data set. I'm going to split out the holdout data. I'm going to read the training data. I'm going to pre-process it. I'm going to start selecting algorithms, whichever ones are the best ones, and going to then try and, transform the features. I'm going to select the best ones, feature transform. I'm going to try out different types of transformation. I'm going to optimize the settings of the model, what's called hyperparameter optimization, and then I'm going to give you a league table of how the best ones perform. So I could pick on this one here, which is a random forest classifier. It's using pipeline 8. It's got a star next to it to indicate that that was the best one. It's this one down here. And it was competing against an XGBoost algorithm at that stage because those two got selected as kind of the front runners. And I've hit pipeline 8 here. I can look inside it and I can see how accurate it was. So it's actually only 25% accurate predicting the yes group. It's 98% accurate predicting the no group, but it's a little bit inaccurate predicting the yes group compared to the no group. And you could bias it at this stage. You could actually, one of the reasons why people tend not to use confusion matrices is because they're kind of arbitrary. The guys that ended up in this group are the ones that had more than a 50% probability of being in that group. It's kind of arbitrary. What they tend to use is something like this, which is a receiver operator curve, which says, what's my false positive rate and what's my true positive rate? And you would normally select a cutoff point and say, I'm interested in everybody beyond that point. It also gives me all these other potential statistics here about how accurate the model is. And I can switch it from the holdout score to the cross-validation score, which is what the model was built on, and see if it compares against that. So I could save out a model at this stage and say, no, this is the one for me. And if I return back to my home insurance project here, I should have another AutoAI, which is the banking marketing sample data that we used earlier on, bank marketing sample data. That should be complete by now. Let's look at that. Let's just see what the progress map was, swap the view. So this was using a light gradient boosting classifier versus a random forest. And the one that it chose best of all was this LGBM, light gradient boosting classifier, machine learning algorithm. We can see how that's worked. What's the confusion matrix here in this one? 47, 90% accurate in the yes group and 86% accurate in the no group. So quite different. So you can see that that is how we can use it to build an AutoAI experiment where we're kind of doing a lights off model building and saying, look, go and try out everything you can in order to build the best model. So far we've kind of gone from low code, which is where we're building a visual model, to no code really, where we're just automatically setting it off. The alternative to that would be something like if you started a notebook, if you created a notebook, you could create a notebook and you could have a Python notebook. You can see I start a notebook here, and I could edit this notebook here. This is if you're used to working with Python notebooks. You can see it's instantiating a runtime for the notebook example because it needs a runtime as well. It needs some resources in order to run this. And if I didn't want to use the modeler flow, and if I didn't want to obviously use the AutoAI, and I just wanted to type in code, I could do that within the same project and combine that together as a example, a stream of work. In this case, it's just creating a little code book for us. And we've got code here that we can run like print hello world and maybe later run that if we so wished, at that point. So you get an idea here. We've got, this is Python. We could also have R if we so wished. And if we return back to the home insurance project itself. You can see all the different elements that we have there. So that's just using, what did we have? We had a notebook, we had an AutoAI experiment, and we had this visual flow using the modeler flow capabilities that we have. We return to new task and just point out all the other things we could have had in that same project. We could have had a data refinery project, we refine the data. We could have had training models and distributed data. We could have combined different works, different streams of work together using using our ability to combine models together. We could have solved optimization problems. So lots of different additional tasks we could have given it at this stage. Okay, so hopefully that will give you some sort of overview of how to get into and how to work with the Watson platform under its current IBM Watsonx.ai livery, if you like. You should bear in mind you can try this out for free yourselves. So all you got to do is just go on there and create an account. They don't tend to hassle you very much, I find, and you'll get a certain minimum degree of resources that you play with. But it's a great way to then, just have a poke around and try out some of these procedures. And there are usually samples and little walkthroughs and various videos on the internet which will help you get started to play around with it. Especially useful if you wanted to play around with the new generative AI capabilities that allow you to play with open-ended text. Okay, you should be aware that we have a number of online training materials which are free to Smart Vision Europe customers or available for purchase for non-customers. And we offer a range of consulting services both on the Watson platform and on other technologies, including open source technologies. So this could be anything from purchasing 1 to 2 days of consultancy time to have an expert work alongside you, or to give you 3 to 5 days of analytics advice, investigate your data and analytical strategy and present you with recommendations, or perhaps something deeper where we're actually developing an application with you, an analytical deep dive, if you like. You can also source your software directly from us, including access to Watson and to client technology that you've seen, or have formal classroom virtual training, informal bite-sized training split over time. And we generally provide advice and no strings attached support to customers and non-customers alike. So if you've got questions you just want to ask, the best thing to do is just reach out and ask us. For our IBM SPSS product customers, we offer tracked technical support, formal technical support services around the IBM SPSS product line. In the meantime, we look forward to you logging in again in the future. Thanks for logging in now. I hope you found that useful. Stay tuned for a link being sent out to you with a copy of the slides and a link to a recording of the demonstration. Thanks very much.